104. Okay, so we have angular and linear velocities, which is just speed, right? And so your angular velocity is angle per time, okay? How much it rotates in any given amount of time. And we use the Greek letter omega, which just looks like a fancy W. And so our angular velocity formula, so it's angle per time, is just that omega is equal to whatever your theta is over your time. And your angle could be in degrees, radians, or we could talk about it in the amount of revolutions. And your time could be in hours, minutes, or seconds, right? So here is your angular velocity formula. We'll get on that? All right, so linear velocity, there's really three different versions. And what I ended up giving you, like I felt like was the best one, is the one that the textbook actually uses. That's really not the one that is the most helpful all the time, but it's good for you to be able to think through the different ways to look at it. So depending on what information you have, you can get it and it can make sense to you. So the linear velocity is distance per time. So it's going to be like feet per second or something like that. And if you're using an angle measure to do this, like if you have to plug everything in from scratch, then you have to make sure your angle is in radians. So if you're going to use your angular velocity, which is one way to do it, you have to make sure your angular velocity is in radians per whatever, okay? Because it could be that you found it in revolutions per second, but what you really need it in to go farther is radians per minute or something like that. But I'm going to show you an easy way that I know you have done things like converting like this in the past, whether it be in, a science class, or probably more likely in a science class than in a math class, but and our distance could be in inches, feet, whatever. And then these are some conversions you got to make sure that you know. All right, so your angular velocity, I was going to add this up here. This is your omega, right? And then your linear velocity is just v for velocity. And because angular velocity is in radians always, remember a radian measure is just how much the radius goes around the circle. And so what we want here, since we actually want a distance, we need to know what the radius is. And so the velocity formula is just the radius times the angular velocity. Okay, so if you already found, it's one of those things where if you already found the angular velocity, you just multiply it by the radius, bam, there's your linear velocity. Your angular velocity formula, though, is theta over t. So this is the same thing as r times theta over t. Again, understanding how you could write it like that is important if, let's say, we're looking for the time or something like that. And then r times theta is just your arc length. What letter do we use for arc length? S. So r times theta is just s, so this is the same thing as s over t. Any one of these three versions here works. Okay, this r omega is probably the one that's going to be the best. Okay, I don't know why I can't learn. Like I still look at what they do in the textbook, and I think I want to make sure that you have that so it matches. Y'all don't ever look at the textbook. Have you ever even logged into your pre-cal textbook? Okay, it wouldn't kill you though. I'm just saying some of those lessons are not so bad. Well, I shouldn't say that. I haven't really watched any of the pre-cal lessons from the textbook. I know from the other contents that we have with that, they're not bad, so I would imagine the pre-cal wouldn't be bad either. But this is your linear velocity, right? So now let's make all this make sense, right? A little bit more sense than I did the other day. Now remember, front and rear tires, okay, they have the same linear velocity, okay, so because they're covering the same amount of distance in the same amount of time, right? Otherwise, it's not going to stay together. It's going to be like a slinky dog or something. But they have different angular velocities because clearly this one's going to have to be rotating a whole lot faster, okay? All right, so let's look through, we're going to work through some of the same problems, work through them a little bit. Oh, no, I need to change my, I think that is, yeah. So this clock problem, even though, again, I think we figured it out, I wanted you to see how you can think through this to make sure that your brain is on the right track when you get stuck. Because the way I just got stuck on something simple here, does that ever happen to you when you're working through problems? It happens, right? And sometimes it's the easiest stuff that you're like, I don't get it. This is the hardest thing ever. And it's like so easy. All right, so it says find the angular velocity. So angular velocity tells me that I'm doing omega equals theta over t. Okay, angle over time. And it tells me to do it in radians per second, okay, of the second hand of a clock. and express your answer in terms of pi. It's important to keep up with your units on here, kind of writing them as you go is important. So a second hand of a clock, right, and it says in terms of pi, and we want it radians per second. So your angle, when it goes all the way around, what's your radians to go all the way around the clock? 2 pi. Okay, so this is going to be 2 pi radians over, and it takes 60 seconds to get all the way around the clock, right? And this is a second hand, so that's how long it's going to take it, is 60 seconds. So I look back up here. It says I'm supposed to have radians per second. I've got radians per second, so my units are good. And then I'm pretty much done. I just need to reduce it, and that's where I get pi over 30 radians per second. Okay, and that one ends up being pretty simple and straightforward, not a whole lot of converting there. Everybody good with that? Okay, so now this one, which was like the hardest question ever for me on Thursday. Angular velocity in radians per second. So again, I want radians per second of the minute hand of the clock. Okay, so again, it's omega equals theta over t. So I know that it's still 2 pi because we're talking about 1 revolution. So it's 2 pi radians over, it takes a minute hand. If I want to think in terms of minutes, I mean, I can think in terms of seconds too, and that's kind of how I ended up doing this. But a minute hand doesn't take 1 minute to go around the clock. That's where my brain was on Thursday, and that does not even make any sense. It takes how many minutes for the minute hand to go around the clock? 60 minutes. You can say it takes 60 minutes, or you could even put 1 hour here. We can think in terms of minutes. So it's 60 minutes. Now, before I reduce anything, I'm looking at my units here. Now, it says I'm supposed to do radians per second. All right, so this is in radians. That's good. This is in minutes. And even though I know you can convert the minutes and seconds just fine, let's just, again, we're going to do all these the exact same way. I'm going to multiply that. Now, I need to convert. So I need to change the minutes to the seconds. In order for my minutes to cancel out, they're in the denominator here. They need to be in the numerator here. And I want my minutes to change to seconds. Put your units in first, and then decide where your numbers go so you don't get it backwards and weird. So I know to convert from minutes to seconds, that's 1 minute for every 60 seconds. Then when you look at this, your minutes cancel out, right? And now I've got my radians per second, which is what I needed right there. Y'all have done that like in chemistry, right? Just that's all you have to do. I made this way harder than it needed to be on Thursday, which made it way more confusing, I know, but again, I could not even process anything. So now, even still before I multiply, I'm going to reduce some more. I can go ahead and reduce this 2 and this 60, so that goes in there once, it goes in there 30 times, right? Try and reduce as much as you can before you multiply. It makes it way easier. So I multiply straight across, and I'm going to get pi over 1800 radians per second. Everybody okay with that? Make a little bit more sense? We're good. All right, so let's look at the propeller problem. We actually didn't do this one. I was trying to skip for time, but I want to go back and look at these because I like the B part on this. Any questions? Stop me if you have questions or if it still doesn't make any sense. Okay, so it says the propellers on an average freighter have a radius of 4 feet, so R equals 4 feet. At full speed ahead, the propellers turn at 150 RPMs. Okay, so that means that's 150 revolutions per minute. I want the angular velocity in radians per minute. Okay, if I want the angular velocity, does my radius even matter? No, radius has nothing to do with angular velocity. Like, it gives me that, but I don't need it. My angular velocity is omega equals theta over t. So tell me what the 150 RPM even represents in this problem. Revolutions per minute. And revolutions per minute is what kind of measurement? Like, what is that? It's not a distance. It's how far, it's how much it rotates in an amount of time, right? Isn't that your angular velocity? So didn't they pretty much give it to me? They didn't give it to me in the units I want, but they gave me the angular velocity, right? So they gave it to me. That is just 150. And anytime you have a rate, something per something, you make it into a fraction. That's 150 revolutions for every 1 minute. Does that make sense to you? That's all it is. Revolutions per minute. You make it into a fraction, you put your units on the numerator and the denominator so nothing will get confusing. Because I know y'all can convert these things in your head, but when you do that, have you ever done it backwards, like you multiplied when you were supposed to divide or vice versa? And you can get yourself all mixed up in that easily. But what I want is radians per minute. So my minutes are good. It's my revolutions that I need to change, right? So since I want the revolutions to cancel out, these go in the denominator. I can do a straight conversion from revolutions to radians, right? That means for every revolution, I have how many radians? 2 pi. Right. And then my revolutions cancel out. I'm left with radians per minute, which is what I want. I reduce if I can. There's nothing even in the denominator, so I just multiply straight across, and I get 300 pi radians per minute. Easy enough? Okay, so a ship's propeller, I'm not even going to, I don't know, a propeller, I don't know what a ship's propeller looks like, but I know what like a boat propeller, like kind of look like that. I don't even know how many there are, but usually 3, something like that, right? It's kind of what a propeller looks like, but they're curved, and I'm not even going to try. So we were looking for the angular velocity at the tip of the blades, which means it's like a point on the outside of the blade, right? That's its angular velocity. And on the second part of this, it says, I'm looking for the angular velocity at the center of the propeller. So right here, what do you think the angular velocity is? It's like where the bolt goes. Is it even moving? Nope, it's 0. Because it's just that point in the middle. The point itself isn't moving, right? It's like what you hold down to spin that around. Make sense? So the very, very center is not moving at all. Okay. All right, then what is the linear velocity in feet per minute at the tip of the blades? Okay, so now I'm looking for linear velocity. Linear velocity, we have a few different versions of that. But I have the angular velocity. So since I have that, I'm just going to use r omega, radius times the angular velocity. So the radius, did they give me that? Yeah, it's 4 feet, right? Okay. And then I'm going to put it over 1 there, times, and I have this in radians per minute, right? It was 300 pi. So this is 300 pi radians for every 1 minute. All right, so I need this in feet per minute. Anybody see any issues with what's going on here? The radians is like in there. I'd have like feet radians per minute. Okay, so here's something that I want you need to kind of stay with me here on this so I can show you what's happening here. If I just think in general, my velocity is equal to the radians times this. I'm not the radians, I'm sorry, the radius. If I wanted to solve for the radius, doesn't that just mean that the radius is equal to the velocity divided by the angular velocity, right? So velocity, in this case, the linear velocity, would be feet per minute. Feet per minute. And then the angular velocity was in radians per minute, right? What do you do when you divide fractions? You multiply by the reciprocal. So this is really feet per minute. The radius is equal to feet per minute times minutes over radians. So the minutes cancel out. So your radius, even though we talk about it in feet, it's feet per radian. Think about that. It's how many feet for every 1 radian, because the radian is just how many times it's the radius that bends around the circle. Does that make sense to you? So this radius, which is just in feet, radians a lot of times the units you don't even kind of write down, but I don't want you to think it just disappears, because there's no magic here. You don't get to just like make a unit go away, which is sometimes what you try to do and you don't know what to do. Oh, it just went away, I don't know. So it doesn't just disappear. This is technically one right here, 4 feet for every 1 radian. And even if you don't write that in there every time, just know that if you have like feet times radians over minutes, those radians don't really count as a unit, because here these just cancel out. And what I want it in is feet per minute and that right there is feet per minute, and so it's 1200 pi feet per minute. And so the question that, Zeke, I'm not sure I even ever responded yesterday, and I know that y'all asked me this on Thursday when I didn't do a good job of explaining anything. On your homework, do I want it in terms of pi, or do I want it with a decimal, like pi multiplied in? I think the directions say that pi multiplied in. I'm fine with exact answers, except that some of those problems, exact answers don't make sense because of the kind of information you were given. Does that make sense to you? Like when they give you the whatever in decimals, you leaving it in exact form is just weird, because you shouldn't have a decimal with pi. So if you're having to work real hard to get it in an exact form, don't even worry about it. And you can do them all in decimals, because again, I think that's what the directions say. I'm just not worrying about it here because it's not really necessary. All right, so again, at the center of the propeller, so let's just think about a circle. This, just the point right there, which a point has no dimensions, right? Has no size or shape. How fast is that point moving? 0, it's not. All right, so it's 0 feet per minute. Everybody okay with that? All right, I want to do, yeah, we're going to do the next couple because I want to look at just the conversions here. Make sure you're comfortable with that. All right, so we got the Ferris wheel problem, right? Because what we did, the way I reasoned you through this, is that we converted some stuff before we put it in, which again is fine, but sometimes that's dangerous because sometimes we do it backwards or we can't even think about minutes and seconds. So it says, Dandruff and Elephant are riding a Ferris wheel. Dan observes that it takes 20 seconds to make one complete revolution. So I know that one revolution is equal to 20 seconds. And their seat is 25 feet from the axle of the wheel, which means that the radius is 25 feet. Okay, so those are important things for me. And then it says, what is the angular velocity in revolutions per minute? Right, so my angular velocity is theta over t. So what I know right now is I know that for every one revolution, it takes 20 seconds. Right? One revolution takes 20 seconds. But I want this in revolutions per minute. So my revolutions are good. It's my seconds that are bad. So seconds has to go in the numerator, and I can convert from minutes to seconds. So for every 1 minute, there is 60 seconds. Right? And then my seconds just cancel out. So now I have revolutions per minute, and that's what I have left. That's good. That's what I want. I can reduce before I multiply. That goes in there 3 times and once. So I'm left with 3 revolutions per minute. Everybody okay with that? So now I've got some options here. I've got, for the degrees per minute and radians per minute, I can start from scratch every time, or I can use the answer I already have. And the answer I already have is sort of reduced for me. So it's still theta over t. And right now what I know is that it's 3 revolutions for every 1 minute. And I want this in degrees per minute, which means my minutes are fine, got to change the revolutions. So 1 revolution is how many degrees? 360. So my revolutions cancel out. I'm left with degrees per minute, which is what I want. 3 times 360 is 1080, and then degrees per minute. Any questions? All right, so radians per minute. I could use this answer, I could use this answer, I could start from scratch. I don't think I want to use that answer because the number's kind of big, so I think I'll use that answer right there. And that still starts with theta over t, so I'll just start with the revolutions per minute again. I know it's 3 revolutions for every 1 minute. I need this in radians per minute, so my minutes are fine. My revolutions go down here so that they will cancel out. And this is radians. So 1 revolution is how many radians? 2 pi. So my revolutions cancel out, and I get 6 pi radians per minute. Everybody okay with that? Just a lot of converting. You just keep up with your units and you're good. Okay. So now it asks me for my linear velocity to the nearest foot per second. Right? So linear velocity, again, I already have my angular velocity, so I'm going to just use r omega. Can I choose any one of those angular velocities to use? Or do I have to use a specific one, right? What do I have to use? The radians. It has to be in radians. So this is the one that I have to use, right? I know that the radius they gave me is what, 25 feet? So this is going to give me 25 feet times angular velocity, which is 6 pi radians for every 1 minute. So that's not any converting, that's just me substituting stuff in. So remember, there's really kind of this invisible radian down here, so my radians are going to cancel out with what's down here. You don't have to write it in, just understand that it just kind of isn't there anymore. I need it in feet per second, so the feet are good, the minutes are bad. So minutes up here, seconds down here. So I get feet per second. 1 minute for every 60 seconds. Then I can reduce before I multiply, right? 6 goes into 6 once, goes into 60 10 times. And then can I reduce some more? The 25 and the 10? 5 goes into 25 5 times, goes into 10 twice. So I think I've reduced everything I can. You got to make sure you can read your handwriting and you don't forget something in there. So I get feet per second, so it's 5 times 1 pi. Don't forget the pi. So this gives me 5 pi over 2 feet per second. So minutes canceled out. Does that make a little bit more sense than it did on Thursday? Okay, good. And I know it's worse when I have to go back and try and fix something. It's way easier just to teach it well the first time, but that didn't happen. So, all right. So this has got some good converting in it too. That's why I wanted to just go ahead and we'll just go through all of them. And if we don't get through everything we're supposed to do today, that's fine too. We're a little bit behind. It's all good. I just adjust things in the end. How fast is okay, so the rear wheels on the tractor are 4 feet in diameter and turn at 20 RPMs. So when you read this, because these aren't very long and the numbers aren't that bad, but it says a 4-foot diameter, which means your radius is 2 feet. For reals, that's like one of the biggest mistakes people make, so just write down what the radius is. And then I know I've got 20 revolutions per minute. Now I'm looking, it says how fast is the tractor going in the nearest foot per second. So even if you're not sure if that is linear or angular velocity, it says feet per second, so what does it have to be? Linear, okay? So my linear velocity is r times omega, right? But I don't have the angular velocity here, so I'm going to write this as my angular velocity. Well, I do, but you might not recognize it as that, but I haven't actually calculated it. That is just r times theta over t, which whether I write it like that or not, I can put my information in there. I know the radius, it's 2 feet. So this gives me 2 feet over 1, technically over 1 radian, not equals, dang it. Sorry. Times theta over t, well that's revolutions per minute, right? So that's going to give me 20 revolutions for every 1 minute. Before I multiply or reduce anything, I'm going to convert this because I have it right now in feet times revolutions per minute, but remember really what's down here is the radians, and this has to be in radians, and that's why it has to be in radians for you to be able to cancel those units out basically. So I'm already in feet, so that's good. My feet are good. And I need to get these revolutions into radians, and I got to get the minutes into seconds. So revolutions go down at the bottom, radians at the top. So 1 revolution for every 2 pi radians. Right? And that helps my revolutions cancel out. That now gives me radians, which will cancel out with that, so that's good. So now I've got feet, but I'm still in minutes. So I have to multiply to put my minutes on the top and my seconds on the bottom. So 1 minute for every 60 seconds, and then my minutes cancel out. So now I've got it in feet per second, and everything's converted. Okay, everybody with me? So now I can start seeing if I can reduce. All right, well, 20, I can reduce the 20 and the 60, right? 20 goes into 20 once, goes into 60, how many times? 3 times. And then nothing else in the numerator is divisible by 3, so I'm done there. But I've got 2 times 2, which is 4, right? So this gives me 4 pi over 3 feet per second. All right, everybody good? Yes? All right. So now it says the front wheels have a diameter of only 1.8 feet. What is the linear velocity of a point on their treads? So a tractor, okay, we've got the front wheels, and we've got the back wheels, right? The back wheels are bigger. This is our 2-foot radius. This is our 1.8-foot radius. Linear velocity. I'm sorry, what? Dang it, thank you. 1.8 is the diameter. Seeing if you're paying attention again. Good job, good job. All right, it is 0.9. See, oh, it's bigger now. I was hoping I would get through today better, but I guess if that's all I mess up on, we're good. 0.9, okay. The point out here, linear velocity. How are these two linear velocities related? They're the same. Don't the tires, they cover the same amount of ground in the same amount of time? Otherwise, the tires are going to keep up with each other. They have different angular velocities, same linear velocity. So when it says, what is the linear velocity? Well, it is what we have right there. It is 4 pi over 3 feet per second. Everybody good with that? So then it asks me for the angular velocity. Well, I have the linear velocity. I need the angular velocity, right? So my angular velocity is r times omega. Just like anything else, we're going to substitute in what we know, and then we're going to go from there. We know the linear velocity, right? It is 4 pi thirds, and that's feet per second. And I'm putting the units in there like this so that we can keep up with them, right? That's equal to the radius. Do we know the radius? Yes. The radius is what? 0.9. So this is 0.9 feet times the angular velocity. So if you always think about your whole, when you're dealing with fractions, if you always think about the things that are not fractions as fractions, it's going to make things a little bit easier. I need to get W by itself. So I am going to multiply by the reciprocal, right? So that means that omega is equal to 4 pi feet for every 3 seconds times 1 over 0.9 feet. Everybody with me so far? Now, I haven't actually multiplied anything out yet, but we'll get there in just a second. I'm just going to take this, and we need to convert. Okay, so I'm going to leave it like that. That's equal to 4 pi feet for every 3 seconds times 1 over 9/10 of a foot. I need it in revolutions per minute. Right now, it is in radians per second, technically, because remember, this is like radians up here. So this is feet per radian. So this is really radians per second once my feet cancel out. I need it in revolutions per minute. So I'm going to convert. I'll first convert my radians. So radians have to go down here. Revolutions. 1 revolution for every 2 pi radians. Yes? So radians cancel out. And then I have my revolutions. I need minutes instead of seconds. That should be times, not equals, sorry. And then seconds have to go on the top, minutes in the bottom. So 60 seconds for every 1 minute. My seconds cancel out. So now I have revolutions per minute. All of that is multiplication. So if I can reduce anything before I move forward, that can be very, very helpful to me. Although I do have a decimal in here anyway, and we're going to just multiply in the end, but we'll go ahead and reduce. 3 goes into 3 once. It goes into 60. How many times? 20. I can reduce the 2 pi. The pi's just cancel out from each other, right? And then 2 goes into 2 once. It goes into 4 twice. So right here I have a 2, I have a 1, and I have a 20. In the denominator, I've got a 1, which doesn't really matter. This 0.9, and the rest are 1s. So I really get 40 divided by 0.9 revolutions per minute. Can you reduce that without a calculator? Doesn't that mean 40 divided by 9/10? Yeah? Isn't that the same as 40 times 10 over 9? Which gives you what? 400 over 9 revolutions per minute. Which in this case, a decimal would totally make more sense if you wanted to think about speed. I just didn't want you to have to worry about getting your calculators. Everybody okay with that? Any questions? Does that help some? Are you going to be able to complete your homework now? Okay. How many of you completed it 100%? Okay. Good job. If you need to keep it, you can to go back over it. And what I'm going to do on this one is I think tomorrow I'm going to give you a take-home quiz. So really it'll just be like another assignment. So you just have a take-home quiz on this so that I'm not killing you with it. All right. And what we were going to do today that you already wrote on your calendar, we're just going to do that tomorrow. You've got like 10 minutes left. Go ahead and glue this in, get out your assignment. If you tried any of it and didn't get it and you think it still doesn't make any sense, let me know. I'll answer your questions individually, but I'll just give you the 10 minutes to work. Okay. This one? It was this one. Okay, so you need to figure out what like where it is on the circle and be able to count through it. And we're actually, no, we're not tomorrow. I was thinking, I think we're going to kind of talk about it again tomorrow, but we're not. So for instance, this one, well, you figure out what you can divide by. So here, this 135, it's like right here. These are your special angles. So if this is a special angle, it has to be divisible by one of these. If it ends in 5, you know 45 is your only shot, right? So it takes 3 45s to get there, because 3 times 45. So if 45 is pi fourths, then you have to do 3 of those, so it's just 3 pi fourths, and that's it. Some of them you reduce, and some of them you don't. Okay.
Something like 10 and then
Oh, okay. It's, well, that I think that is something that we're doing tomorrow. Where you're just, okay, so what that is, and yeah, that's on the circle that was all the triangles. Do you have that? That's what that is. I know what you're talking about now. Okay, so every ordered pair here is just an ordered pair of cosine sine. So if I ask you for the cosine of 45, that's your answer right there. Okay. If I ask you for the cosine of 135, then you know that that's a multiple of 45 and it's in the second quadrant, right? And that it's right here. So it's the same numbers, but it's just negative because cosine's negative here. Does that make sense? So if you have sine or cosine, they're just right here. If you have secant or cosecant, it's the reciprocal of these, but sometimes you have to rationalize the denominator. Do you remember doing that in geometry? Okay, and in algebra 2. And then tangent is just sine over cosine. So if I want the tangent of 60, I just take the sine value, put it over the cosine value, and simplify. What's going to be most helpful for you is if you think about these as a set of 3 instead of a set of 2. Like once we figure out the tangent values, you might want to write them out here. And when you get here, you know it's 1/2 square root of 3 over 2, and then what the other one is. That way you don't have to calculate it every time. And because we're going to be using them so much, it'll become much more Yes, you'll just kind of know, and you'll be able to relate them to each other a little bit better, and I'll give you some ways to remember that stuff. But that's all that is. Does that help a little bit?
Yeah.
Okay. All right. We good? All right. Yes, sir. Oh, thank you. I have to go back and edit some.